In Unit 5, we are getting into chemical bonding and chemical naming, how it is that we name chemical compounds. We're going to start off with a quick review of chemical bonding. So, chemical bonding, by definition, is the joining of atoms by a strong attractive force, creating a new substance. So we have two or more atoms that are attracted to one another, and as a result, it results in a new substance being created. As atoms move closer to each other, the nucleus of one atom will begin to attract the electrons of another. And we saw that in our bonding tutorial yesterday, that the nucleus can start to pull on a different atom's electrons. Okay, as a result, electrons are either transferred to the atom or shared between the nuclei. And this right here is the fundamental difference between an ionic bond if they are transferred or a covalent bond if they are shared. The type of bond then that forms depends on the electronegativity of each of the atoms. And we've talked before in our last unit about electronegativity. So we're going to quick review electronegativity. Before we get into that, just remember, atoms form chemical bonds because they are hoping to achieve a full outer shell of electrons. Okay, remember a full outer shell for most cases is 8 valence electrons, so we refer to this as the octet rule. There are, however, some exceptions to this rule, such as helium, which is content or considered having a full outer shell with only 2 electrons. So, back to electronegativity. Electronegativity is defined as the ability of an atom to attract electrons in a chemical bond. Okay, essentially what happens is as these atoms move closer together and the nuclei start attracting the opposite atom's electrons, there ends up being a tug of war over these electrons. Recall that the higher electronegativity value is always going to attract the electrons more strongly. And so as a result, a higher electronegativity value means that atom is most likely going to get those electrons. Okay, every element on the periodic table has an assigned electronegativity value. Okay, there are no units associated with this. They're just used sort of for comparison reasons. Okay, as atoms add valence electrons, they become closer to having a full outer shell, so they attract electrons more, which is why they have the highest. Remember, things that attract electrons more have very high electronegativity values. And when we looked at our trends in electronegativity in our last unit, we knew that the halogens had the highest electronegativity values. Remember, they have 7 valence electrons, so they are looking to just gain 1 electron. Atoms that easily lose electrons then have very low electronegativity values, such as our alkali metals. And if you flip over your periodic table, you will see that there is an electronegativity table found on the back. And so those are the numbers that we are going to use later in the unit when we get into bonding.